Hello everyone. Welcome to lesson 3, which is on molecular formula. In this lesson, we're going to be looking at how we take our empirical formula and convert it into a molecular formula. Let's take a look. So if you remember, in lesson 1, we talked about what an empirical formula was, and we learned how to go from a molecular formula to an empirical formula. In our second lesson, we learned how to go from percent composition to our empirical formula. And in this lesson, we're going to learn how to go from empirical formula back to our molecular formula, kind of bringing us full circle. Now, if you remember, in order to go from our molecular formula to our empirical formula, we identified what was called the greatest common factor, the number that was divisible evenly into each of our subscripts. Now that we're going in the opposite direction, we once again need to figure out what that greatest common factor is. However, because we don't know the molecular formula, we don't know what number would divide evenly into each of its subscripts. So instead, we have to figure out the greatest common factor using another method. So in this case, what we're going to do is we're going to find the molar mass and the empirical formula mass and figure out how many times our empirical formula mass will fit into our molar mass. This will also equal our greatest common factor. In these problems, you will be provided with a molar mass or molecular mass for the compound. Let's take a look at our first example. It says, we are going to identify the mass of the empirical formula, which will either be provided or calculated. We will divide the molar mass of or molecular mass, depending on what we're given, by our empirical formula mass. And then finally, we will multiply the subscripts on our empirical formula by the result that we get. So in our first example here, we have an empirical formula that is equal to 1 carbon and 1 hydrogen. You might recall that carbon has a mass of 12.01 grams per mole, and hydrogen has a mass of 1.01 grams per mole, giving us a total of 13.02 grams per mole. So as I mentioned, we are going to divide our molecular mass, which is provided to us in the problem, by our empirical formula mass. So molecular mass divided by empirical formula mass. So in this case, we have 26.04 grams per mole divided by our 13.02 grams per mole that we just calculated, gives us an answer of 2. That answer is our greatest common factor. We found it using a different means, but that is our greatest common factor. So the last part that we need to do is to take our empirical formula, CH, multiply it by our greatest common factor, which in this case is 2, and we're going to be left with our molecular formula, C2H2. Let's take a look at another example. In this case, we have an empirical formula of N2O5. So we're going to look up our value for nitrogen on the periodic table. We'll find out that nitrogen has a mass of 14.01 grams per mole, but I have 2 of them, so I'm going to use 28.02 grams per mole. So nitrogen times 2. And we have 5 oxygens. Each oxygen is 16.00 grams per mole. 5 of them will be 80.00 grams per mole. And our mass here will add up to give us 108.02 grams per mole. At this point, we're going to do exactly what we did in our first example. So we have our molecular mass. We have our empirical formula mass. We're going to divide those two. So 216.04 grams per mole divided by 108.02 grams per mole. We get an answer of 2. So our N2O5 empirical formula, when we multiply it by 2, will give us N4O10. This will be our molecular formula. Now we're going to take a look at a third example. In this example, we're going to combine what we just learned about molecular formula with what we learned in lesson 2 about empirical formula. So in this problem, you can see that we're provided several percentages. We're going to use our empirical formula poem that we learned in lesson 2 and convert from percent to mass to moles, divide by small, multiply till whole if necessary, and then take it one step further and complete the molecular formula problem that we just have seen. Let's start off with our 5.90% hydrogen is going to become 5.90 grams of hydrogen. Our 94.10% oxygen is going to equal 94.10 grams of oxygen. So that's the percent to mass part. Now we're going to go from mass to moles. So we're going to need to look up their masses on the periodic table. So 1 mole of hydrogen, 1.01 grams of hydrogen. 1 mole of oxygen, we have 16.00 grams of oxygen. Notice our unit grams of hydrogen and grams of oxygen is going to drop out. I'll use my trusty calculator here. 5.90 divided by 1.01 turns out to be 5.842, or just 5.84 moles of hydrogen. And our 94.10 divided by 16 turns out to be 5.88. Moles of oxygen. So we're going to divide by small. We essentially get 1 oxygen and 1 hydrogen here. Now, what we can do at this point, since this is our empirical formula, so this is the part that we would have learned in lesson 2. Now we're going to find the mass for this empirical formula. This is what we learned earlier today. So hydrogen is going to equal 1.01 grams per mole. Oxygen is going to equal 16.00 grams per mole. And the total here is equal to 17.01 grams per mole. This is the mass of our empirical formula. So in our final step, we are told that we have a molecular mass of 34.02. We're going to divide that by our empirical formula mass. Which we found to be 17.01. When I divide that, I'll get 2 is my answer. So I can take my empirical formula, multiply it by 2, and get my molecular formula. Let's take a look at our last example. In this case, we are told that we have an unknown compound. It has a molecular mass of 86.20 grams per mole, and we're told that the sample is 16.40% hydrogen. So if we know that hydrogen is equal to 16.40%, we're going to change that to 16.40 grams of hydrogen. There are only 2 compounds, or 2 components rather, to this compound. So carbon has to equal the missing percentage. So the 82.60% that's missing, that's going to be due to carbon. So we have 16.40%, which will become 16.40 grams of hydrogen. We have 82.60%, which will become 82.60 grams of carbon. Now we can convert each of these into moles. So 1 mole of hydrogen, 1.01 grams of hydrogen from the periodic table. 1 mole of carbon, 12.01 grams of carbon from the periodic table. So we get 16.24 moles of hydrogen. We get 6.878 moles of carbon. Just like we learned in lesson 2, we're going to divide by the small. So we're going to divide them both by 6.878 moles. Here we will get 16.24 divided by 6.878 turns out to be 2.3. So in this case, what we're going to end up doing is multiplying by 3 to get our whole number. So in this case, we'll wind up with C3H7. This is our empirical formula. The next part would be for us to go ahead and calculate the mass of this empirical formula. So carbon, we have 3 of them. That's 12.01 times 3, 36.03 grams per mole. Hydrogen, we have 7 of them. Each hydrogen is 1.01, so times 7, we get 7.07 grams per mole, for a total of 43.10 grams per mole. This is our empirical formula mass. The final step in this process is to take that molar mass that they gave us, this 86.20, molar mass or molecular mass, and divide it by our empirical formula mass. So 86.20 grams per mole divided by 43.10 grams per mole turns out to be 2, which again is our greatest common factor. Now we can multiply that through. So C3H7, multiply that by 2, we'll get C6H14. This is our molecular formula. Okay, that wraps it up for the last lesson this week. What I would like you to do is complete the assignment on molecular formulas. Please let me know if you have any questions, and please stop by office hours and I'll help you out. Thanks a lot, everyone. Have a great week.